In this video, we're presenting the PRISE, a process to conduct I-star extensions and illustrating the use of this process by revisiting an existing extension. The PRISE is based on a set of references which define that modeling languages are often modified to represent new concepts or modifying existing ones. An extension should be represented in three levels. Initially, the description of the meaning of the concepts to be added by the extension should be done. It's also required to apply the extension to the abstract syntax of the modeling language, in other words, to its meta-model. Validation rules can also be proposed when necessary. It's also necessary to apply the extension to the concrete syntax of the modeling language so that the designers can use it. Logically, the consistency between them must be maintained. The Moody's work, Physics of Notations, presents a set of principles related to the definition of the concrete syntax of modeling languages. We are using the principle semiotic clarity, which defines that a construct must be related to a single graphical representation and vice versa. Thus, there are four types of problems that may occur. Symbol deficit, when there is no symbol in a notation corresponding to a particular concept. Symbol redundancy, when multiple notation symbols can be used to represent a single concept. Symbol overload, when a single symbol represents multiple concepts. And symbol excess, when a symbol does not correspond to any concept. These concepts were used by a systematic literature review, which will be presented in the next slide, and also during the definition of PRISE. As mentioned, we performed a systematic literature review to identify I-star extensions. Thus, we identified 96 extensions from 2001 to 2016. We identified that 42.7% of I-star extensions not present or partially present the definition of the concepts introduced, which represents incompleteness and inconsistency of these proposals. 62.5% of I-star extensions are not represented in the meta-model, which also represent incompleteness. 77.8% of I-star extensions which have abstract syntax of both syntaxes do not represent part of I-star nodes and links, so they are non-conservatives. 37.14% of I-star extensions not have compatibility between the abstract and concrete syntax. That is, it has inconsistencies between the syntaxes. 108 conflicts of semiotic clarity were identified in I-star extensions. Examples of these conflicts are given following. Service has two representations, so it characterizes a symbol redundancy. A triangle is used to represent a norm, duty, predicate, and action, so it characterizes a symbol overload. Motivated by the results of systematic literature review, we performed a qualitative study followed by a survey. Then, we interviewed 20 experts in I-star extensions. During the interviews, we identified how these researchers proposed their I-star extensions and what can be done to improve these extensions. The main results were represented as statements. These statements were submitted to 30 other experts to confirm or refute their importance to the community. Statements considered important were used to generate 9 guidelines. We used those guidelines and other suggestions given by the experts when we were creating PRISE. Some highlights of the PRISE are: it is based on the literature of modeling language and our previous works. Its purpose is to conduct the proposal of I-star extensions complete, consistent, and without conflict, so we created a set of tests and artifacts to reach this goal. PRISE also intends easier the reuse of existing extensions by a catalog. It is based on the guidelines of the I-star community, and we proposed a process with a very detailed activities flow so it can be used by novice researchers without experience in I-star extensions or by experienced ones. This is the main process of the PRISE. It has a set of 5 sub-processes and one task which are executed to propose an I-star extension. The sub-process 1 analyzes the need for extension proposal. If there is a need for extending, the flow continues, otherwise it is not proposed. Then, the flow is parallelized. Occurring the description of the concepts, the extension is developed and the validation occurs. At the same time, it is checked if other new constructs are identified. At the end of this step, it occurs join of the flow. When new constructs are identified, these 3 sub-processes are executed again for these new constructs. And when there are no constructs identified, the I-star extension is publicized and the development is finalized. The document of the extension specification, which has the extension detailing, is involved throughout the process. Note also that the extension development is based on a set of guidelines. These guidelines will be presented now. Guideline 1 refers to preserve the constructs of the original I-star syntax of the extension, in other words, doing conservative extensions. Guideline 2 highlights the need to carry out consistent, complete, and without conflicts extensions and follow a process method to do them. Guideline 3 suggests performing a literature review, the participation of domain experts and I-star experts in model systems of application area before extending. Guideline 4 establishes the need to describe clearly the meaning of extension concepts. Guideline 5 points that the extension should be represented in both syntaxes, abstract and concrete. Guideline 6 it's relevant to check the consistency between abstract and concrete syntaxes. Guideline 7 suggests relating the concepts introduced by the extensions with I-star concepts. Guideline 8 recommends defining extensions with the smallest possible number of modifications and new representations. And finally, Guideline 9 points to the importance of the purpose careful and simple graphical representations able to be drawn on paper without a tool. We highlight that these guidelines are a result of the qualitative study that we cited on slide 5. Let's analyze each sub-process of PRISE, starting by the sub-process 1. This sub-process consists of several activities, but simple ones. The sub-process begins when there is a need to propose the extension. Then, it is verified the purpose of the extension. If it's to an application area, the extender should study the concepts of that application area and generate a list of references and researchers contacted. Next, the activity 1.2 consists of identifying the concepts to be introduced by the extension. If there are any questions related to the domain researchers should be contacted to solve these doubts. The extender receives a response from the domain researchers and has their doubts mitigated. If you have any questions on whether you can model extensions concepts with standard I-star syntax, the extender models an example with I-star. If you have any questions about I-star modeling, or if you can model the target concepts of the extension with I-star constructs, the extender should contact I-star experts. Thus, the experts mitigate doubts, the extender receives the response, and the flow continues. If it's possible to model the concepts with I-star, the process finishes without the need to propose the extension. Otherwise, it is required to check if there are extensions that model the concepts of the new stretch being proposed. If there is an extension that models the concepts, the process is also terminated without the need to propose a new extension. Otherwise, the flow follows with the creation of the initial extension a specification. This specification groups the artifacts produced in this subprocess. In the task 1.10, the extender uses a catalog of iStar extensions. This catalog is a repository of the extensions identified in the systematic literature review that we mentioned at the beginning of the presentation. The extenders can search extensions by the author, title extension, constructs, among others, and is available in the link that's displayed on the screen. The flow returns to the main process when the subprocess 1 finishes. If there is no need for extending, the process is terminated without a new extension being proposed. Otherwise, the main process flow continues. The next subprocess is 2. This subprocess starts when the need for extending iStar is confirmed. Initially, there is a search and selection of the constructs to be reused. The repository of iStar extensions can be used during the search. Then, the concepts of extensions are described, and it's analyzed how to integrate the constructs with the iStar constructs. This integration is possible when some new construct specializes in iStar construct or some link that connects them, for example. If there are any questions related to this integration, the experts in iStar extensions can be contacted to mitigate it. And finally, the extension specification is generated with the concepts described. The execution returns to the main process when the subprocess 2 finishes. Following, the subprocess 3 starts the extension development. Then, the subprocess 3 starts after the definition of the extension concepts. Therefore, these concepts are introduced in the meta model, and when necessary, validation rules are created. At the same time, the concrete syntax of the extension is defined. A checklist for verification of problems is used to verify the completeness, consistency, and conflicts. This checklist will be presented next. It is feasible for the extender. The tool must be created to support extension. And finally, the results of this subprocess are added to the extension specification by task 3.6. The checklist for verification of the problems is used to verify the completeness, consistency, and conflicts. The completeness section checks if the meaning of the concepts were defined, if the extension was applied to iStar meta model, if validation rules were created, this item is optional, and if the extension was represented in the concrete syntax. The following section verifies the presence of links and notes of iStar default syntax in the meta model and the concrete syntax of the extension. The third section deals with the consistency analysis. It presents the list of the concepts that the extension is included and it checks if each concept has its meaning and if it's present the meta model and concrete syntax of the extension. Finally, it is verified if any conflict of semiotic clarity principle occurred. In the subprocess 3, there is a subprocess 3.5. This subprocess consists of 4 tasks: to implement the extension in the modeling tool, to test and correct it, and make the tool available in a link. The flow returns to the main process when the subprocess 3 is finished. Following, the subprocess 4 is executed to validate and evaluate the extension. In the subprocess 4, the extender must use the extension to model a system to illustrate the use of the extension. Then, If there are corrections identified during the illustration, these corrections must be made to the extension. Following, the expert can be consulted. Let's detail the sub-process. The experts in iStar extensions and in domain are involved in the sub-process to receive validation of them on the process. Let's now return to sub-process 4. Therefore, if the expert suggests corrections or improvements, the extender should apply them and use the checklist again to check if the absence of problems has been kept. The extensions should be evaluated by a qualitative and quantitative study. If there are improvements identified during the evaluation, they should be applied to the extension. And finally, the extension specification validated is generated. The flow returns to the main process after the sub-process 4. It is tested if new constructs have been identified by test 5. If there are new constructs, the main process flow returns to the description, development, and validation sub-processes for these new constructs. When no new constructs are identified, the iStar extension is publicized by sub-process 6. The new extension must be added to the iStar extensions catalog. When there are experts in iStar extensions involved in creating the new extension, they should endorse the extension in the catalog and it will become public. If there are no experts involved, the extender should notify experts to endorse this extension. Finally, the extension should be published in a conference, blog, or journal. Thus, the extension creation is finished. It is important to highlight that PRISE is a reference process to conduct the creation of iStar extensions. It was proposed in the most detailed possible way so that both inexperienced and experienced researchers could use it. However, it is possible to instantiate the process by adjusting it for the specific needs of the current project. We recreated an existing iStar extension using PRISE. This is an extension used to select cloud service providers based on security and privacy requirements. It represents threats, vulnerabilities, security and privacy goals, security and privacy mechanisms, security and privacy restrictions, cloud actors, and it implements restrictions and satisfaction links. We identified inconsistencies once the meaning of security measure, privacy measure, security mechanism, privacy mechanism, and implements link were not defined in the paper. These symbols appear in the abstract and concrete syntax, so we decided to keep them in the extension and include their meaning. We added the meaning of these concepts according to what's presented on the slide. We also kept the meaning of other concepts that were already in the paper. The extension meta model is displayed on the screen. It is possible to identify that test meta class and iStar relationships are not present in it. Besides, we find 4 meta classes in the meta model which are not represented in the concrete syntax. There are organization goals, malicious actor, deployment model, and service model. We decided to remove these meta classes from meta model because their meaning and graphical representations were not presented in the extension. Therefore, we created a new meta model for the extension without inconsistencies. In other words, we removed these 4 meta classes and included all elements of the iStar default syntax. We have identified some conflicts. For example, vulnerability was represented by the same symbol used to represent belief. Furthermore, the satisfaction relationship conflicted with the link from another iStar extension. So, we followed the guideline 9, which recommends following a careful way to propose these representations. Then, we followed the approach suggested by CARE, and finally obtained new graphical representations with vulnerability and satisfaction link. Finally, we can conclude that we have corrected inconsistencies and conflicts from the original version. Therefore, the PRISE has been efficient.